Now, your client-server technology is a network architecture model that uses computers or processes on a network as either a server or a client. There is a possibility you can be both. But a server is something that is the source of services or data, and the client is what's connecting to that server to use those services or that data. The client-server architecture has got a number of advantages, such as shipping the work out among multiple servers. So, I don't have to have my computer do it all. I can put my files on another location, a server, and get them when I need them. And I can have multiple locations, right? I can spread that work out. There are some business challenges, though, in the client-server technology. You want to look at how well they're dealing with the rapid growth and complexity of a client-server environment. I mean, we're adding in now into the world of client-server where the servers are virtualized machines, where the servers are now in the cloud, right, wherever that is, and we're connecting to it. I mean, we know where it is. It's with the service provider that's providing it for us. We have servers that are being clustered. So we have, multiple servers pretending to be one to give us better performance. Right? The complexity is just getting bigger and bigger and bigger. More companies are moving to the client-server platforms, especially for mission-critical applications. I just mentioned the cloud. Cloud computing is everywhere. Companies are experiencing a lot of problems sometimes with integrating their application changes to that existing network system because of the complexity of the network. You can also have a problem with high staff turnover because, you need to have people that are skilled with the type of client-server technology you're using. And with a high staff turnover, you might have a constant hiring, which means I have to constantly train people to be able to support those client-server technologies. And you might even run into the problem where companies have numerous office locations, and maybe they have an aggressive merger acquisition strategy. And so because of that, they don't have a centrally located client-server system, and that adds in the complexities of clients and servers communicating over wide area networks, and that's bad or good. It just depends on what your goal is, I suppose. Generally bad because a WAN is a slower link than the local area network. So what's the solution? You want to be able to address the business challenges that management has using the COBITS delivery and support domain. Now, this domain is concerned with the actual delivery of required services. That would include service delivery, management of security and continuity. It also addresses your service support for users and the management of data and operational facilities. Now, what the domain typically addresses are things like, are IT services being delivered in line with the business priorities? Are the IT costs being optimized? Can the workforce use your IT systems productively? And is there adequate security in place? So it's a good outline for us to be able to go out there and begin to have a framework for what we should be looking for, questions we should be asking, documentation we gather in working with network technologies. Another client-server technology we deal with is called middleware. Now, client-server is a specific term that we use to talk about the class of software that's employed by the client connecting to the server. The middleware can serve as glue between two otherwise distinct applications and can provide services. Of course, they can also provide services for the audit of authentication, of authorization, directories, and security. We see middleware helping us with things like transaction processing. Microsoft Transaction Server is a combination of that. And what's that mean? That means, let's say I want to order something, right? And I know that when I place the order, that a transaction is something that happens 100%. Contact the bank, contact inventory, contact shipping. And what if one of them is down? Well, then the transaction gets rolled back. But what if that's okay? What if it's okay that it's down? I've got some middleware that's going to keep trying and trying and trying and trying for you. It's going to hold that up and until it makes the connection, can confirm it for you. It's doing your transaction processing. We also know the middleware can help us with remote procedure calls. I may need to call some software to do something special that's not on that server, it's somewhere else, so it can do an RPC over there. It uses these things called ORBs, the Object Request Broker technologies, which again is a way of distributing the business application to different locations. Could be a messaging server. There's a lot of cool things we can do with middleware. Well, the risks of middleware can come about against the system's integrity because of the very purpose that middleware was designed to do: support multiple operating systems. That means if you have a lack of proper software controls, we're in trouble, because we're talking about portability of data, portability of programs across multiple platforms, and that can result in the loss of the data or program integrity. Now, your controls aren't limited by management to ensure the integrity of the client-server networks. Management should ensure that the systems are properly tested and approved. So, all right, we can have controls from the vendors. We can have controls all the way through the process. It's not just the management that can ensure that the integrity is going to work.